the unit step function. The function itself is pretty simple. It's just 0 or 1. For negative values, it's 0. For positive values, it's 1. It's a step. If you shift it over, say u of t minus a instead of u of t, then it's going to be moved over here to a point A. What happens if we combine more than one of these? If you had u of, say, t minus 4 and u of t minus 10, there are three possibilities, right, on the number lines. Something's going to happen below 4 and above 10 and in between. If we're less than 4, then this is u of a negative and this is u of a negative, so they're both 0. If we're more than 4 but less than 10, like say 7, then this would be u of 3, this would be u of negative 3. This would be a 1 and this would be a 0. If we take something bigger than 10, this is going to be a 1 and this is going to be a 1. Now suppose we subtract these functions. We'll have a function that is 0, then it is 1, then it is 0. In other words, we have a single step up and step back down. So what if you had some random function f of x? F of x times 1 would just be f of x. F of x times 0 would just be a flat line. And then f of x times u of x, for negative x, this is a 0, and we have f times 0, which is 0. For positive x, this is 1, and we have f times 1, so we would get that. Likewise, if we have f of x times u of a minus u of b, we're going to have a to b. The function is going to be 0, then it's going to become that part of the function, and then it's going to be 0 again. Multiplying a function by these two step functions subtracted is a way to isolate a piece of that function.